Right, today's lesson, you're going to be learning how to present experimental data on a graph. But more importantly, why do we need to be able to do that? This entire section is about experimentation, what you do in the lab as you're investigating the relationship between physical quantities. So, for example, the relationship between force and acceleration, the relationship between length of a string and the mass of a pendulum, or the relationship between the angle of a slope and how fast a car moves down it, or how the current is affected by the voltage. Basically, all the things that you're going to be investigating follow that format. How does A affect B? Cause and effect. Now, all of these relationships, because there is physics behind them, because they are physical relationships that are ruled by physical laws, they all end up being expressed by mathematical equations. It's all about the equations. Mathematical relationships can be expressed by a graph, so that's where you're going to start. You're going to go into the lab, you're going to investigate the effect of A on B, and you're going to draw a graph. Now, these graphs will give you your equation, and a good investigation ends with an equation to express the relationship between two variables. Whether you're doing when you are doing an investigation, basically, you're doing one of two things. You are either proving a relationship is true, or you're trying to find the relationship in a new thing. And yes, there are still relationships to be found out there. That relationship has to be a mathematical relationship, has to be expressed as an equation. And the reason or the way that you are going to get that equation is by looking at a graph. So, experimentation goes like this. You go into the lab, you research what A does to B, you plot a graph, you look at the shape of your graph, and the graph shape tells you the equation. Now, this is what I mean by there's two types of research question. The first one, how does force affect acceleration? That's very much an how does A affect B? It is asking you to find the relationship. So in the end, what you're going to end up doing is coming up with a conclusion, F equals ma. That's the conclusion. Exactly the same thing, but in a different way, is to say that my research question is to prove that the relationship equals F equals ma and applies to a car moving down a slope in a laboratory. So what you're going to do in the end of this experiment is still come up with F equals ma, but then you're proving it, you can then justify it with respect to your hypothesis. But this is what we mean by this bit here. When you're doing an investigation, you are either proving a relationship or finding the relationship. And this is an example of that. Okay. All physical relationships end in equations, and this is where you're going. Now, this would include your IA, right? So your internal assessment in physics and probably in chemistry and environmental sciences as well. What you're doing there is you are going to find two quantities and you're going to try and find the mathematical relationship that goes with those two quantities. So let's get started thinking about how do we end up with that equation? Now, as I said, you go into the lab, you take your readings, you then plot a graph, and you look at the graph shape. There are lots of different graph shapes, but I think we could probably just summarize it into two. Your graph is either linear or it's curved. And by curved, these are just a few examples. You've got power curves, the ones that slope in this direction. You've got inverse graphs. 1 over x squared, for example, is a really common one in physics. You've got root graphs, etc. Anyway, so your graphs are either going to be straight or they're going to be curved. And if they're curved, you have to try and figure out what the relationship behind the pattern is. So what you're going to be doing over the next few lessons is learning how to go from a graph which is curved to the equation. You're going to have to try and identify the equation which rules that behavior. But first, let's start with some graph drawing basics. When you're investigating a relationship, you definitely have to start with your independent and your dependent variable. Your independent variable is what you control. So in the case of force times mass, we're looking at a relationship here. Graph of acceleration versus mass for a cart moving under the influence of a constant force. So what we're doing is we're changing the mass and we're seeing how the acceleration changes. In this case, the independent variable is the mass of the cart and the dependent variable is the acceleration. So how do we put this on a graph? The rule is that the dependent variable always goes on the y-axis. The independent variable always goes on the x-axis. So the first thing you need to get clear in your mind is, in my relationship, what is the independent variable and the dependent variable? And make sure that you put them on the right axis. Independent on the x-axis, dependent on the y-axis. It's also vitally important that you label each axis with the variable and make sure that you put the correct units in. Sounds obvious, but you'll be amazed how many people forget. Now, when choosing to scale your axes, that means when you're choosing these divisions here, there are some interesting tips that you should take up. The important one is that you always try to use up as much paper as possible. What we're looking for is that these points take up more than half of the entire paper. So don't give me some tiny little graph to look at, or don't make the scales so that the points go really close together, because I know that sometimes makes it look like it's a straight line when there isn't one, right? But that does not count. You have to use as much of the paper as possible. Look at the range in your data. So look at the largest thing that you're going to spot. And from that number, the largest value, that's where you work out your scale. Make sure that you're using a sensible scale. Don't use numbers which are really awkward, like 1.3, 2.6. Try and keep the numbers as regular and as straightforward as possible. Maybe increments of 1 or 0.5, etc. And if you need to, use a false origin if you have to. But from now on, the actual intercept with the y-axis is very important. So even if you are using a false origin, you might actually need to then do it again, showing exactly where the intercept is. So be careful with that. Choose a graph title which is going to help understand what's actually on your graph. Okay, so the title is really important, and the more specific the better. So here we have the gravitational potential energy of a 5 kilogram mass versus distance from the center of the earth. So it's very clear, it's telling you exactly what's on there. So in addition to labeling the axes, ensuring that your scales are sensible, all right, make sure you've got a nice clear title. And that's it for the first video on graphs.